FCFS scheduling. So this we have already done in the previous video, but we'll just see. The turnaround time and waiting times are calculated by using what formula? Turnaround time is completion time minus the average time. We write it as TAT is equal to CT minus AT, and waiting time VT is equal to TAT, turnaround time, minus the burst timer. So now this question, 5 processes with process ID P0, P1, P2, P3 and P4 with given arrival time and burst time is shown in the table. Calculate the average waiting time and average turnaround time for the given processes. So P0 arrival time is 0, P1 arrival time is 1, P2 arrival time is 2, P3 arrival time is 3, P4 is 4 and burst time are given. We need to find the completion time with the Gantt chart. So how do we do this? Okay. So we will first see this. At time 0, which process has arrived inside the ready queue? We have process 0 which has arrived inside the ready queue, because the arrival time of process 0 is 0 units. And how much time it takes for its completion? It takes 2 units in the CPU. So we write here 2 units taken for completion of P0. Now P0 has been completed at 2 units. So now how many processes have arrived? The processes which have arrival time equal to 2 or less than 2 have arrived. So process 1 has arrived in the ready queue and also process 2 has arrived in the ready queue. So this is the ready queue. So initially process 0 was arrived, then we have process 1 arriving, process 2 was also arrived, and process 0 has completed its execution and it has exited the CPU. Now process 1 has arrived at 1 unit time. So process 1 will come first inside the CPU. Why? Because in the FCFS we will always consider that process which arrives first. So P1 arrives first. P1 arrives at 1 unit time. It arrives first before P2. So we will take P1. And P1 takes how much time for its execution? 6. So 2, 6, that is 8, 2 plus 6. Now P1 will leave the ready queue. Now P1 has arrived at 8. So the processes which have their arrival time equal to 8 or less than 8 will arrive in the ready queue. So you will have P3 arriving because it is 3. 3 is less than 8. P3 arrives in the ready queue. This is the ready queue. Even P4 arrives in the ready queue. P4 arrives in the ready queue. So now P2 will be given the first priority because it has arrived in the ready queue first. First come, first serve. The one which arrives first will be given first priority. So we give priority to P2. P2 will take how much time for its complete execution? 4. So 4, 8, 9, 10, 11, 12. 4 plus 8. After P2 will now leave the ready queue. P3 will come inside this Gantt chart. P3 is arriving at time 3 units and the burst time, that is the time which it takes to complete its execution, is 9 units. So 12 plus 9 is how much? 21. P3 will leave the ready queue because the P3 has exit. Next is P4. So then P4 will arrive. P4, it takes how much time to complete its execution? 12. So 21 plus 12 is 33. So P4 will also complete its execution and exit the CPU. So now the ready queue is empty because all the processes have completed their execution. So your completion time will be for P0 from 0 seconds to 2 units, from 0 to 2 units. So completion time will be 2. For P1 it is till 8. So completion time will be 8. For P2 it is till 12 units. So completion time will be 12. For P3 it is till 21 units. So completion time for P3 will be 21. For P4 it is till 33 units. So completion time will be 33. Turnaround time, we saw the formula, it is nothing but completion time minus the arrival time. So my completion time is 2 minus 0 is 2. 2 minus 0. Then 8 minus 1, that is 7. 12 minus 2, that is 10. 21 minus 3, that is 18. And 33 minus 4 is 29. So when you add this, you add 2 plus 7 plus 10 plus 18 plus 29. 1, 2, 3, 4, 5 divided by 5, you get 13.2. Average turnaround time. Now waiting time is nothing but turnaround time minus the burst time. So turnaround time is 2. 2 minus 2 is 0. 7 minus 6 is 1. 10 minus 4 is 6. This is 18 minus 9. And this is 29 minus 12. So when you add this, you add 0 plus 1 plus 6 plus 9 plus 17 divided by 5, you get 6.6 as the average waiting time.